Okay, hi. My name is Kerry Brace, and I own Dark Horse Cues. I make custom-made pool cues for people, just breaking cues, and I have a website, darkhorsecues.com. And I do CNC work and have a small little CNC mill, and I decided I wanted to make a larger CNC machine. Well, first of all, I wanted to see what the price was on the market out there for something that would work for me. I don't need a 4 foot by 4 foot table or 4 foot by 8 foot table. My shop isn't that big, and that isn't what I do. Since I work on pool cues, I simply wanted something that was a little about 4 feet long and anywhere from 18 to 22 inches wide. Something I could probably work on 2 or 3 cues at a time on if I wanted to, and I wanted a 4-axis machine. After looking at the market and looking at what it would take to get a custom table made for me, you were looking at $5,000, $6,000, $7,000 upwards. There's some machines out there that are really nice, that'll do the job, but I'm not in that kind of budget frame that I wanted to be able to invest $7,000 or $8,000 on a CNC machine. Luckily, I figured that I could budget about $2,500 for a CNC machine, and I was able to come in a little bit under that, which included everything: linear rails, ball screws, the 4-axis controller box, which we'll talk about a little bit later, and all of the aluminum and all of the screws and all of the everything. And I machined all my own parts. I designed the CNC machine in SolidWorks just to give me a rough idea of what I wanted, and then as I progressed through it, I made some mistakes and I got some things that worked out really good and everything. But luckily enough, I have a friend of mine, John Howard, that owns Howard Fabrications here in Rapid City, South Dakota, who has a very nice machine shop, and bless his heart, he let me use his nice milling machine and his big torque lathe for being able to do some of the stuff that I needed to do. And luckily I brought back some of my schooling, my machining schooling, to be able to run that stuff, and made some nice parts, which makes it important. This is not a cheap build. This is a build that I really wanted to spend the money on to have a quality machine that would end up giving me quality parts, and quality equipment, costs money. But to have all of the parts machined by somebody else, it probably would have been around $5,000. And luckily, since I had somebody that let me use their shop, I just bought all my own aluminum and built everything myself. So what I've done is I've already actually done a full assembly, and then having everything, and then what I'm going to do from here is I'm going to go through all of the parts that I have and assemble it and go in a little fast order on the video, and then put it together and get it up and running for you. And then I'm going to use Mach 3. And I've just started using Fusion 360 for CAD. Luckily for me, I have SolidWorks training, and then I'm also used to using Mastercam. And so I've got a good experience on the CAD-CAM thing. So the Fusion 360 is a combination of both of those, and having originally been trained on AutoCAD from Autodesk, it's kind of neat to see them and what they're doing out there in the market. So I like the combination of that, but I digress. Anyways, what I'm going to do right now is lay out all the parts and explain what they are and what I did and why I did it. And then the next video we'll go through, start doing the assembly. And I'll try to do this in several, 3 or 4 videos. They'll be about 15 or 20 minutes long, and something that's not too bad. So what I have here is I already have the linear rails bolted onto this L. It's a 1x3, and I decided that because I'd be able to set this on the table like I've done here, and the table's upside down right now, so I'd be able to have my linear rails, and then when I have the table set up, my end plates fit right inside here. And I decided to go with a hidden rail system versus having the rails out in the open. I didn't like the idea of having the rails sitting out in the open and having to constantly clean stuff off of them. I'd like to preferably just to wipe it down once in a while. And then the middle support goes in the middle. So this is the form of the table, the basic form of the table minus the legs. Okay, got the legs. I decided, well, I wanted to put the legs on the inside. The legs ends up sitting like this. And by the way, all of the aluminum that I bought, or almost all of the aluminum that I bought, besides getting some from a local steel and recycling place here in Rapid, I've got from 8020.net, which is a really good supplier for very good quality extruded aluminum, and that's what I ended up using for the bed and for the cross members. Speaking of the cross member, this is the top edge of the gantry. And what I decided to go with a little bit different design than some people would do. For accuracy, because you want this thing running as smoothly as possible and very accurately, you end up needing to have a very solid parallel. Everything's got to be exactly parallel and in sequence with each other, which wouldn't have been too bad if I wanted to go with two linear rails on this. I wouldn't have room for my ball screw, so I would have had to go with a wider. And I didn't want to stop myself from having enough room between the gantry and the tabletop. So I decided to put the linear rail on top, like that, and the ball screw in the middle. And the ball screw sits in the middle like this. These ball screws, by the way, are absolutely the bomb. These things are great. If you decide that you're going to build something like this, be very careful about taking this off of the end of here in case you want to turn it around or you're doing something else or anything. The screws, the balls inside, the little steel ball bearings, are free floating, and these little pads here are recycling pads. What they are is it allows the ball bearings to go up, go inside, and come back one rotation and go back and cycle through until the other end where it goes back and goes through one rotation. And there's one in the middle and one on both ends. And these will fall out if you take this off along with all the ball bearings. So put a piece of tape around it if you decide that you're going to take this apart. I don't recommend it unless you have to. I ended up having to, because what I ended up doing was, because the width of my table was a very particular width, when I ordered my kit, I decided to order just a generic kit for a 4x4 table, which allowed me to have an extra long ball screw that I could cut down and make for so I have some extra ball screws, which will be great because I think that I probably want to build another one, maybe a smaller version or something like that. But anyways, I ended up having to cut this. Now these are case hardened. They're only hardened on the outside, and so the metal on the inside is fairly soft. It's certainly turnable. I was able to put this into a lathe with a 6-jaw lathe that my friend John has, and be able to machine this down. So that and then thread this on so that I could put the pillow block on this end, the pillow block on this end with the little snap ring set. You'll see how this gets assembled later on. And then thread it. It was still fairly difficult because it was hard, but it worked out pretty smoothly. So that's pretty nice, and the ball screw ends up sitting in there. The gantry, the whole gantry system ends up sitting on this, like this. And I have this already mostly assembled. And yeah, I machined this part. I looked around and I looked at spindle motors and decided that buying $300 or $400 for a spindle motor for something that I don't do threading with my CNCs, so I don't need a full stop and reverse direction. So that's the main reason that you might want to use the spindle motor, besides the precision of being able to control the speed of the cut, which is really good. But so what I did is I started looking around, and I found a really nice router made by Hitachi that had a cylinder base in it. And let me grab the router so you can see what I'm talking about. The router by Hitachi was 2.5 horsepower, or 2¼ horsepower, and it has the swivel base on it, which rotates off. There we go. Get the base off of here. So that it's just like a spindle motor, and it's a variable speed. It's a nice quality router for $100. These, you can get these on sale at Menards. On off sale, they're about $120. It's a variable speed. It has a soft start and a soft stop brake, so that when it's running, it's very quiet, and it really does have a good speed control. You've got a if the dial says 1 through 6, but it's anywhere multiple in betweens. Let me plug this in here so you can hear a little test on this. So I'm running, I haven't geared it out exactly, but I think that I'm running at about 300 or 400 RPM here, which if I did want to cut any aluminum or anything like that is probably the maximum speed that I'd be going if I was using end mills and stuff. But for what I do, it works really good, and you can do the speeds however you want. And so I took the measurement off of this, I machined it so that it would fit right in here. And then my ball screw runs up and down. And again, it's really important that when you do these that you're parallel with everything. So on the back of this, the way that I've got this set up is my bearing blocks go on here and here for the 2 rails on there, and the ball screw goes through the middle. And it's once I have it together, you'll see how it's all set up, and I think that it works out pretty good. Here's the base of my gantry, and because of the narrowness of the table, when you order if you order a linear rail kit from some of the companies that are in China and everything, with the ball screws and everything, they're really nice kits. I think that they've done a really great job over the last 5 or 10 years of improving the quality and the precision of what they make over there for the cost. Either way, though, there are some issues about ordering stuff from China that I'll probably talk about as I go through this, little things that I ran into. But other than that, I think that was great. But anyways, the kit that I got was for a 4x4 table. So literally it came with 4 linear ball screw rails, 2 for each side, because on a 4-foot table you need to have 2 spindle motors or stepper motors running the 2 ball screws for the y-axis, and 2 of them running the ball screws, or 1 of them running the ball screw for the x-axis and 1 running for the z-axis. So they send you 3 full-length ball screws for each kit, and I only needed the 1 for the middle of this, which is right here. The 1 for the middle of this, and the 1 for the x-axis, and the one that they send you, the little 12-inch one for the y-axis. Now 12 inches is a kind of a misnomer. It's really all in metric and everything, and so you have to be careful how you measure that and all that stuff. But just understand that when you're making something like this, that you want to be as accurate as possible. The last thing you want to do is make something that's not going to be accurate. And a lot of the accuracy comes from where you start out from the beginning, the type of materials that you start with, and how careful you are while you're making it. Alright, well, this is my T-slot. It's a 3x1 is the thickness of this. I really liked the heavy duty gauge that 8020.net sent me. And then you can see how I did the linear rail on the 1x3, or it's actually 2x factory. Anyways, when I did all the bolting, I did countersinking for all of these so that I'd be able to slide any nuts down the inside of them. Just got to put the other linear rail on the other side, turn it around and do that, and then we'll put the gantry on. Well, got to put the ball screw in too. Hi, I'm back. Carrie Brace here from Dark Horse Cues. I finished assembling the bed. I use still pictures for most of the assembly because I don't think that most of you people are interested in that. I watched a lot of videos on YouTube about how people made their CNC machines and why they made them, and I saw some really interesting stuff. I saw some really inexpensive stuff, and all of it was very, very cool. I think that people watch this stuff to look for ideas for their own and see what other people are doing out there, and mostly to see the types of CNC machines that they made. If you have any questions about the assembly or anything like that, you can go ahead and text me after I post the video and talk to me about the, send me comments. I'd be honored to reply to anybody. Unless it's negative or nasty, I won't reply to any of that, but I hope that I don't see any of that kind of stuff out there. I've got the legs on the table. I have the long ball screw inset on this. I'll show you about the spindle motors after I get everything up and smooth. On the pictures you saw that the ball screw went through the bottom and was attached and had one of these little blocks on it that has the screws already. These are so nice. I've seen other people that have bought these and then just attached a plate to this, which is certainly okay, but now they send these with these as part of the kit, unless you order it separate or anything. I suggest that you go ahead and buy the kit because it's worth it. One thing we found after this, when I got it, I started counting all these are all 5mm size thread bolts, and I ended up going to, if you have a Fastenal company in your area, go to them because they'll give you the best deal. I went through, I know there was more than 130 of these number 5 size screws in different lengths and everything that I ended up using for this. I've got a few holes to tap before I put the top linear rail on here, and this is all set up for the ball screw to come in this way and set across here. And I'll talk about what happened over here. It wasn't really a mistake, it was kind of a design. As expensive as 1/2-inch aluminum is, I thought that I would be able to cut corners a little bit, and I ended up having to remake this plate because I needed a full-size mount for the spindle motor that comes out on this side. I kind of really wanted the spindle motor to be on the other side, but after getting my bench together and setting this up, I realized I really didn't have room over there. So it'll be sitting out on the side, which is perfectly okay. There's nothing wrong with that. It'll end up leaving the track out on this side too. But still, same thing again, I'll be able to push this almost all the way up against the edge here. And I'll also talk about how I put the blocks on the outside instead of having them on the inside, and then having a motor on this side. You can go either way. I was thinking that I was going to be able to save myself, give myself more travel between the two ends on my x-axis, kind of the same way that I did it on this. I wanted maximum carriage length for the end of this, but when you end up having your blocks, these blocks on these rails, and you have 2 of them, and this ends up being mounted in the middle, or even on the end. If you mount it on the end, you're going to lose the 4 inches on this side. If you mount it in the middle, you're going to lose the 2 inches on this side. The reason that I ended up having these blocks on the outside on the length was that I ordered everything at the same time. I ordered the 1300 millimeter linear rails and ball screw kit and figured that that was about 48 inches, and I wanted a 48 inch bed, at least a 48 inch bed. So I ordered the linear rails and I ordered the aluminum from 8020.net and had them, cut them to length, all these pieces that I set in here, and all the 1.5 by 3 inch L-shaped track that I put this on. And then after getting the whole kit, realizing that 1300 millimeters was really about 2.5 inches longer than the 48 inches, putting the blocks on the outside. I actually, and I'll show you on the other end, had to put a half-inch plate. It was either that or rearrange the whole thing, and I didn't want to mess with that. So throwing a half-inch plate and moving the block out another half inch was no big deal to me. Personal preference. Again, if you've got the time and you want to set it up, I was kind of in a hurry. I wanted to be able to get this done this summer, and I haven't had too much of a problem other than that now. But anyways, I'm going to go ahead and assemble this and put it in, and I'll take pictures as I go through each step. I don't think you guys want to sit there and watch me assemble it, but I will take pictures of everything, and then I'll talk about the issues that I had when I put it together. Okay? Thanks. See ya. Alright, this is a practice run for a drill pattern. There's, I think there's 16 holes to drill. I did them in a pick order using Fusion 360, and there's the G code. And here's my CNC machine, all set up to go. Don't need that half-inch collet out there. And I'm going to hit the cycle start button right there. Let's see how it goes. Nice little peck in, 100ths of an inch at a time. I should say that. Hearing a little humming. I need to check the speed and traveling, because it really shouldn't be humming like that. It should be traveling a little smoother. So I'll check the feed rate and see if I don't have it set up a little too high, or the acceleration a little too high. I'm not sure. Yeah, that's it's okay. I mean, it's not hurting anything except for that. Yeah, that little buzzing right there is just a little bit of feed control. I'll have to tune it in. There we go. Worked out pretty good, except for you can hear that grinding sound. It isn't grinding, it's really the speed versus acceleration in the motion control configuration. If you go to motor tuning, there's what I've got this set at right here, and it's either the speed or the acceleration, one of the two, but I'll check that out later. Okay, hi again, this is Kerry Brace from Dark Horse Cues, and this is my completed CNC machine. I did add in limit stops to it, and I wanted to talk about those. And I wanted to talk about a variation I did. I ended up remaking this plate right here. In the original video, you'll see that the plate was, and it was too high. I didn't have enough height. I wanted to be able to lower it more, and I ended up adding, I thought I'll just go ahead and put in some extra plate holes so I can lower this more if I needed to, in case I need it to be up higher or lower or something, and ended up doing that, which is nice. Being able to change something like that on your own is good. On the last video that I had, when I finished the video, I had completed everything, and I had promised that I would talk about setting up these spindle motors and configuring them for speed. So I'm going to do this holding this camera in my hand and making sure that you guys can see what I'm doing. I ended up getting everything the way that I wanted to, and I'm running Mach 3 as the software for the software program on this, and my little controller box is what came with the 4-axis controller, and it's okay. It isn't, you know, I don't need to use it. It's capable of doing memory and redoing and duplicating processes and stuff like that. I just have never needed to have anything to do with that. But what I did need is I needed something that was really accurate, and this thing's doing a really good job of being able to cut very accurate, very small little pieces repeatedly over and over. The one thing you'll notice on here is I have this nice little LED light ring, and I'm probably going to do another little video on how I made that, but I ended up doing that on a plastics printer, and I used SolidWorks to design it. That's one of my favorite programs, so I use SolidWorks to design it. But now I've opened up when you open up Mach 3 and you're getting ready to tune in your motors, and I'm going to walk through how I did this. What you want to do is, here's a couple of the things that I ran into when I first installed Mach 3 and I set up my stepper motors and I wanted everything and started running it, and I was trying to figure out what the amount of steps per unit rotation was and all of that. And of course I had ordered all of the linear rails and ball screws were from China and everything, and it was all metric, and of course I like running in inches, even though I do use metric sometimes. Either way, anyways, once you open up Mach 3 and you go up to configuration and you go to motor tuning, right here is where you set your steps. Now you'll notice that I've got a weird number of steps, 2031.440704, and this is pretty darn accurate. And my maximum velocity for this is about 65 inches per minute, acceleration of 12.5, according to the size of the stepper motor that you're using, and according to the weight of the gantry that you're moving and how much your total weight is. I wanted something very solid, so I used a lot of 1/2-inch plate, so it's pretty heavy. My acceleration is plenty fast for what I need. So I'm going to give you an example of I've got this all set up. So when I go, I've got this at 25% right now. I'm going to set it at 100%. So that as I move the Z up, I get out of steps, make sure that you're out of steps, and go into continuous motion. I'm going to zoom this up. I've got good Z motion. I'm not going to go up to my little limit step. My little limit switch is up there, and the bottom one is under here. And my limit switch for my left is on this side. My right is on that side. This is my LED light ring, and then my limit steps are switches down here are on this side end of my gantry, and what they do is they collide with the legs. So when I go in the Y, X minus X or plus X, excuse me, my condition is really good. So now I already have this tuned into 0 for where I wanted to be able to cut this little part out. I'm doing a multiple cutout. I'm doing these little, it's for a pull cue, and these are little inlays that are going on the pull cue, and this is ivory. And so I'm going to set it back to, I'm going to go to 0. And it'll run down and drop back down into the 0 position. And stop. And I'm ready to do my cuts. So, back to the configuration of the motor tuning. In order to get this accurate, what you want to do is go to Diagnostics, Settings, go to Settings, and right here, Set Steps Per Unit. When you click on this, you're going to get a window that says, what do you want to calibrate? And if you want to calibrate the x-axis, click on X and click OK. And when you go down here, what I did was I took a ruler and set my ruler up on the table, and I moved my spot, the tip of my little 1/32 end mill to 1 inch, and then I moved it what I thought would be, 3 or 4 inches. And what it did was it moved like, I think that when I first did it, I said move 6 inches, and it moved like 3.5 inches. And what it'll do is it'll calculate out the steps. And after you set the steps in there and you click OK, I'm going to close this because I don't need to reset. It's okay, I'm going to abort it. When you go to set the steps, it'll recalculate what it thinks it needs to do that. Because if you say you wanted to move 6 inches, but it only moved 3.5 or 3.625 or whatever you can calculate out for your distance, it'll give you the tool change, save that speed. It'll recalculate the x-axis and then run it again and do steps per unit again, and the further you move it, the more accurate it's going to be. So if you've got a bed that you can move 15 or 20 inches, go ahead and set it on 0, move it a full 10 inches and see how accurate you can be. Now if you really want to dial it in tight, when you get done with the 10 inches at the end, set a dial caliper up, a little edge finder or a dial caliper, so that when you get to the end and it pushes on it, you can get down to those thousandths of an inch. But I was able to get it it ended up being I've got it just set right now, so when I move 1 inch, it moves exactly 1 inch. It gives me exactly the size that I need and the size that I want for everything that I cut out, and it does a really nice job on the pockets that I cut out for my pool cue. So that solves that problem as far as configuration goes, the motor tuning. So once you have this, and as long as you're using the same ball screw for the Z and the same ball screw for the Y axis that you used for the X axis, these numbers, once it's calculated in here, just copy this number. Right click, copy, and then go to your Y axis and right click and paste. Now the one thing that I have different on here is that when I go into my A axis, I've got this down, and mine ended up being what I thought was really strange numbers, 6.6666 on including, forever, steps per rotation, and that was for my rotating my head. And this is in degrees instead of linear steps, so you don't go by inches. And it ends up that when you go with a lower step number, your velocity on this, I've got it at 30,000 and my acceleration at 5,000. So I'm going to show you how that works. When you're in here and you set this up, my 4th axis is my rotary head, and it's running nice. It runs for at a good speed. It doesn't hesitate. I can set in when I want to go to, I'm going to go to MDI here, and if you're familiar at all with Mach 3, you'll be able to do this stuff pretty quick. There's a lot of really good videos on YouTube about how to do this, and Mach support is really good as far as covering and answering questions. G0, A 90, and when I hit enter, that'll rotate 90 degrees. Worked out just perfect, and it shows it as 90 degrees. Okay, I had to change the batteries in my camera. Where was I? I think that I was right here. The emergency off switch. You guys can certainly locate yours wherever you want. I wanted to be able to put mine here so that when I reset this, and I am running this if I need to, and push this, it'll emergency stop requested, and it works great. Wiring these, an interesting thing that I ran into was that in running my limit switch wires on this particular controller, there was the wiring diagram is this is a 9-pin, and you have 6 limit switches, Z plus, Z minus, Y plus, Y minus, or Y plus, Y minus, and X plus and X minus. Those, the only thing that it doesn't do is, since it's 9-pin, it's asking for your 4th axis, because this is a 4th axis controller, that you have a limit switch for your A, your 4th rotation. Well, I don't want a limit switch on my rotary head, you know, we would never be able to do more than 1 rotation, or I don't know how I'd even think about setting up a limit switch for a rotary head for a 4th axis like that. But on this particular one, I didn't need one. So in the cables here, when I ran the cables and I set up my Z, it has, since it's 9 pins, it has one common pin for both the Z and the A axes. So I ended up having to put a little jumper wire from one pin to another, and having, because when I set it up and I had just the 2 wires going for my Z plus and Z minus, or Z as some people say, it wouldn't work. The limit switches wouldn't work, and I ended up having to put a little jumper into the other pin for where the A pin was supposed to, where the A wire was supposed to go, and then it worked just fine. So that was just my particular situation. Some of the things that I did when I wired my machine was I ended up buying Molex 4-pin connectors, so that I was able to connect or disconnect my motors, my spindle motors at need. One of the mistakes that I did make was that I did not set up my soft limits on this. When you you don't have to have limit switches on your machine, but if you do set up limit switches, it saves you a lot of trouble. If you don't, and you just want to use soft limits, make sure that you go to, in order to set up your soft limits, go up to configuration and homing limits. Make sure that you're soft. You'll see that I've got almost a 5-inch throw on my Z. I've got a 12.5-inch pass on my Y, and a 39.25-inch pass on my X-axis, which is plenty big for what I was wanting on my bed. I would have liked to have had probably like 18 inches instead on this, but I would have had to widen this up by at least 2 or 3 more of these, and it wouldn't fit on the bench that I wanted. So I ended up going with this, which is plenty big, because I'm able to fit 2 or 3 pool cues in here at a time and be able to do whatever I need to, and which is just exactly what I was looking for. Now make sure that you set your soft limits on here. If you don't, the machine will run until it stops, and it'll keep on trying to run. And according to how much torque your spindle motors are set at, the little springs that these have, and I'm going to pause this for a second. Okay. On the spindle motors, the coupler that they come with, this is like a 1/4-inch drive shaft for a 13mm drive shaft on the end of your ball screw. They're really nice. These little torsion, or I guess you could call them backlash couplers, allow you to have a little bit of torque at the end, so that it will give the motor time to catch up without losing too much. You're not going to strip it off really easy. Works really good. Having said that, not having my limit switches in set up right away, and having made a mistake on my soft limits, I ended up colliding with the end a couple times, and then my X-axis wasn't working right. It was like jumping. It would start and stutter, or it would move off, and I'm like, what the heck? And I ended up having to take this all apart, only to find that my little coupler had snapped. And what it would do is, if it was turning this direction, it would turn just fine, because it would catch up with that. But then what it would do is, if I went the other direction, it would start turning the other way, and sometimes it would be pushing so hard on this that there would be enough tension in between these two faces, and you can see kind of where it was skipping, that it would actually start turning the other direction. So I had to take this apart and put in a new coupler, and that was okay because it was a good lesson for me and probably good for, you know, being able to tell somebody else, don't make that mistake. Make sure you have your limit switches set up. If you've got if you're able to do the limit switches. If you don't, make sure that you have your soft limits set up on that, on homing and limits. Okay. That being said, that's about all that I have to talk about on this. Wiring diagrams and everything is all this. I originally thought that I was going to have, I look at the Cartesian coordinate plane. I'm standing in front of my machine right now, and I'm thinking X is in this direction and Y is in this direction, because if you look at math, Cartesian coordinates, that's the way the planes are set up. But since the A-axis is in line with when you on most turning programs, and same thing with Mach 3, the turning rotation axis is on the X-axis. So I had to switch these. What would have normally been X and Y is now Y and X. So I ended up switching these, which didn't matter. It didn't matter which way I had those set up. But that's just something that happened with this. I did mention earlier that because I had not made my right measurements when I ordered all of this material, that I had to push this pillow block out a ½ an inch further for this to work. These are little things. I could probably build this thing again and do a lot of things different, like not having to have this exterior. It wouldn't matter if the block was on the inside here, because these stop blocks end up running into this anyways before you get into the end of the pillow block. So, but it still worked out. My machine works really good. I'm very happy with it. One thing is, because I do run the router, I don't have this cable running inside the housing. It's not practical, because I do take the motor out to be able to switch the bits, which makes it a lot easier. I'll probably do another little thing on my little LED light. Like I said, I made that on a 3D printer. I'm going to raise this up. Turn my external emergency switch back on. Raise this up, and you can see. Be able to pull this off. I don't have it on here too tight because it's nice to be able to get it out of the way. But it's 6 LED lights, and they're on little pivot heads, so I can change the angle of them if I needed to. But it wasn't very expensive for me to make, and I will probably put this up on Instructables or Thingiverse for people to make if they've got one, as a pattern that they've got, you know. But not everybody's going to use the same thing. You're going to have to change your design, but the basic wiring and all that stuff is pretty simple. Thank you very much for looking at my video. I hope you guys enjoy watching this. If you've got any questions, please send them to darkhorsecues@gmail.com. Thanks again.